Welcome to the virtual IQAP tour of the undergraduate labs in electrical and computer engineering at the University of Waterloo. This virtual tour uses a virtual reality camera, which will allow you to see the whole room and scroll around while I'm talking. You can use this feature by making the YouTube video full screen, and you can either use the control at the top of the screen to move around, or you can simply just click on the screen and drag and you'll be able to see the full lab. This is our smallest lab. It's the optics lab. It's a fourth year lab, 477. The lab is run on air sensitive, air pressurized optics table, and the majority of the lab deals with fiber optics, optoelectronics. All the equipment has to be stored away for ESD and contamination reasons. But this is where we're going to start, and I'm just going to take you through the different labs fairly quickly, just to give you an idea of what we have here in the department. So this is our fourth year design lab, and also our ECE 298 lab. This is where students come to work with test equipment and essentially assemble circuit boards, soldering, some design, and of course, like the fourth year project, the 498, which is a capstone project, where students have after hours access to come in the lab and use the equipment to bring up their projects. This small lab is our manufacturing lab, so we provide resources to students to do advanced reflow and rework of circuit boards that they've developed. We have a reflow oven system here that solders a complete board at once. We have a screen printer putting the solder paste on the board. The students who come over here put the parts on the board and then put it into the reflow oven to solder it at once. And when they've done that, they have the equipment to test and bring up the board, as well as if there's issues, there's an X-ray machine here that they can use to X-ray through the board to see not only internal layers of the board, but also are the components properly soldered onto the board. This room is open to all ECE students through special access who have projects that they're working on, either home projects, personal projects, could be student teams, but primarily fourth year design projects. So this small lab is another fourth year technical elective lab. It's on robotic systems, and the students get to work with the Now robots, and particularly they're studying robot manipulators and the inverse kinematics of robots. So that's what they use. Lab instructor works with the students, and the labs go, of course, all term, and students come in as groups to work with the robots. It's fairly limited resources here. The lab instructor in charge of this lab is in the room, in the lab office at the back of this room. We do have like 15 lab instructors in the department who are engineers. Mostly all have engineering degrees, many are PEng and graduate degrees, and they work full time just supporting students in the labs. So this room here is one of our higher density lab rooms. There are 40 workstations here. Each workstation has a dual monitor. It's specifically set up for programming courses. So students come into the lab to get support on programming. They can work remotely, but they also have scheduled lab sessions to work with the lab instructor and TAs. As you can see, these stations are set up that it's one student per station, which is not the same as the majority of our labs. This is probably a good room. It's a fairly large room to take advantage of the VR capabilities of this camera, if you haven't already, and just take a look around and see the size of the room. We have a whole bunch of these rooms, and I'm just actually continuing down the hall and showing you room by room. In contrast to the room that I just showed you, which is more directed at programming, this lab here, which is a kind of a lower year, typically second and third year students would use that room. This room here is for fourth year students. This is 2 courses, 44 and 41. And the students use these rather expensive ball and beam contraptions to learn control theory. So they have to write code that controls the position of the ball on the beam. The students get a lot of control experience in this lab. We have like specialized controls lab instructor that takes over this lab. So this room here is maybe I'm over here. I'm not sure if I've moved around in the VR screen. You can scroll around to find me. This is one of our devices labs. So students study silicon devices, transistors, MOSFETs, bipolar junction transistors. There's specialized equipment here, precision source and measurement units that connect to the computer, and then they can plot the response curves of the devices here to understand the underlying physics of the electronic components. If you follow me through the VR here, we'll just step over into this area over here where we have probing stations. So this is where we would put a full semiconductor wafer on the arbor, and students using the microscope can probe areas of the wafer to actually make measurements on components that are on the silicon. And if you see, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 probing stations. So these come out at certain times of the course to provide students with kind of a deeper level of how components work on the substrate. So this lab here is reserved for RF courses. We have some second and third year courses. I'm going to move this camera here just a little bit, so hopefully this doesn't bother you, but it does give you a chance to look around a little bit more from the center of the room. Again, 2 students work at a station. These are smaller classes. This would be strictly electrical, not many computer students would get involved in the RF labs. We have very expensive test equipment. These are vector network analyzers used to understand antennas and transmission lines and stuff, and these units range about $40,000. So this is a well-outfitted lab to provide the necessary learning resources for the students. I think there's 20 stations in this room. People work in groups of 2, so that would be 40 students. And then, like all of our labs, it's typical to have 3, 4, and sometimes 5 lab sessions now per week to get all of the students in the program through the labs, and then 5 labs per term. Distinct labs for each course that has a lab per term. So the last room, the RF lab I showed you, is actually on the other side of the hall. We're working our way back down the hall in Engineering 2 building. This is what we call a circuits lab room. So it's set up with equipment required to do some of the circuits courses, such as ECE 140, ECE 240, ECE 340. We also run, this is like a high voltage unit. We run electromagnetism course out here, which is ECE 106, one of the first year courses that we run in-house. These are big classes because they are, especially things like ECE 106, all the students take it. We're always in kind of an overflow capacity. We have to run, many lab sessions a week to be able to cover all the students in the course. Again, this is a lab that's set up with 2 students to run at each desk. Now through this door, I'm just gonna bring you along. I kind of hate doing this to move people when it's a VR camera, but let's just take a quick look through this door because this lab is so big, a lot of students. Typically what we do is we have this overflow. So sometimes students will run in this lab uniquely, like we have labs running in this room and labs running in that room. But these labs are set up the same. So things like ECE 106, because it's so big, it actually runs in both labs. We have the teaching assistants who are helping the students, and then the lab instructor who's the ultimate authority of the lab, and he'll kind of move, from side to side as need be. We are continuing down the north side of our hallway in E2. This is a specialized lab, and it's used for control theory and communications. So we have kind of both setups here. So sometimes we'll run ECE 318, which is a communications course, and the students kind of work with radio transmitters, radio receivers on the equipment, understand and learn how to signal processing, essentially signal analysis. We also have the control theory set up, and there are a couple courses that run out of here. So we have ECE 380, and then we, which is kind of more, this is kind of like the first controls course that students will run into. And then over here, if you see this back cabinet, you can see motor systems. And those motor systems, you can see kind of a plastic cabinet with the motor in. They bring them out, and then the students will do kind of a motor control system on that, learn how to drive a motor, use the feedback, and to get accurate control of the motor. So this is kind of a specialized lab where we're very proud of the work that happens in this lab. So this is now on a different floor, on the second floor in our Engineering 2 building. And this is the first of our digital electronics and hardware programming labs. So it's kind of a multi-purpose space. We have some of these labs. The students have dev boards. This is an FPGA board. This is used for embedded software in ECE 350. And then we have our logical step board. This was developed in-house specifically for our labs. And it is currently used for ECE 124, which is a first year digital course introducing logic gates and stuff, and ECE 224, which is a second year course in digital electronics, where they'll look at actually making a processor on an FPGA. So it's a really cool course. This room here is basically runs just those two labs. So this is another one of our digital rooms, just down the hall from the other digital room I just showed you. Again, this lab is outfitted with our logical step boards, which we can run ECE 124, and now ECE 327, which used to run on that board, runs on a Xilinx pink board, which we have here in the lab for the students' use. And also we have ECE 320 running off of these boards. These rooms are set up, the equipment is locked down, and the rooms are set up for after-hours access to the students. So they have codes for the door, both digital rooms. They can come in at any time, 24 hours a day, 7 days a week, and work on their projects. So gives them the time outside of the regular lab time to kind of focus in and understand what it is that they're doing in the lab. So this is a lab that we use for another digital lab. We're typically running SE 350 out of this lab, and we have 224, 124. And again, this is one of these labs that has after-hours access for the students, so that's why the students are busy working here right now. Oops. This is our last digital room. It's also, very similar to the other rooms that we've seen. We have ECE 224 specifically set up in this room. You can see that the computers have audio speakers on them, and this is because the students design a MP3 player on the board in 224, and this allows them to read audio files from an SD card and play them on the speakers. We also run other labs out of here, like ECE 423, which is a fourth year digital course, where the students are doing video decoding. Basically, all of our lab rooms are multi-purpose. There's multiple labs that will run in each lab room, and it's basically split up as odd and even weeks. So odd weeks will have some courses, even weeks will have some courses, and mornings and afternoons. So different students, different classes would be coming in for morning sessions and afternoon sessions. It's also worth noting that in our labs, we host labs from other programs that are kind of cross-appointed. So we will do labs for software engineering, we'll do labs for mechatronics, we do labs for nano engineering, and we also, especially in our power labs. So there's a wide range of labs that happen. It's not just for our program, but we do, service them. Our labs and lab instructors service these other programs. So this is a lab that we're, particularly proud of. This is our power electronics lab and machines lab. Students get to work with these systems with safety probes. It's high voltage. So these systems are running, up to 208 volts. All the connections are safety, so there's no way to touch any of the electrodes. In lower courses like ECE 260, they learn three-phase power, and then in upper courses they will work with kind of the machines, and so they have different ones. This is a 4-pole square cage induction motor, capacitor start motor, synchronous generator, prime mover, and a DC generator. So they get to experience running with all these motors. They also have controllers like PID controllers to control the motor speed, and also like power thyristor control. So they, I think fourth year they get to go into power electronic control. So these modules are, you pull the lever and you can pull the module out of the bank and swap things. So they'll actually pull modules from the cabinets to set up for the different courses. We don't service only electrical. This is a very, very expensive lab to build. It's probably about $1.5 million worth of equipment in this room. And so other programs like mechatronics and mechanical get involved in this lab. Sorry, I'm moving the VR camera around. I know it sometimes can, be a little bit uncomfortable, but we'll try and stick with it here. Because I just wanted to show some of these other stations that we have over here. So this is a fourth year course on power distribution and relaying. So how do you protect the power lines? You have a short down the line. How do you, where do you open up gates? How do you protect the whole power system? So these are relaying. It's a relaying system. So they get to learn how to program the relays that detect, faults down the line. They have a way to introduce faults. So that's it was one of our fourth year power courses. So that's basically it for this area, the power lab. I have one more lab to show you. So we'll head up to the other building to see our semiconductor fab. So I apologize about the noise. That's just how it is in a clean room. This is a multi-million-dollar clean room that's set up for strictly undergrad students to do experiments with semiconductor device processing. So students would go to ECE 231 and then on to ECE 331, where they start to work with semiconductors, and ECE 433. So they would be manufacturing transistors on wafers. It's after 6 o'clock, so most of the lab instructors have gone home. But our clean room lab instructor is here, so she's in the video tour. As far as the equipment goes, we have the wet benches, which are over here. Over here we have the CBD sputtering machine. Have the RIE machine over here for etching. And then back here in the clean room, we have the lithography room. And so students would transfer patterns onto the mat before they etch the patterns on. The light in this room is set up to keep the wafers from being exposed before the UV light comes on. This is more of a testing room. They used to test the samples when they're done. They have ways to check the resistivity, elastometry. So there's a number of things that they would check when they're working. In behind here, this wall is electrical tests so that they can perform measurements on the wafers that they manufacture here. Again, my apologies for moving you around through the tour. So this lab is fairly intensive, and for safety reasons, students come in pairs to work with the TAs, and constant oversight by the lab instructors. They work through the steps to manufacture silicon wafers. This, of course, is a clean room facility, so all the students have to gown up when they come in here. But it's a really good experience for our electrical students who are interested in the semiconductor area of electrical engineering. So again, this is the testing room I mentioned in the clean room. There's parameter analyzers here. Students use a probing station here to measure their wafers and to check the performance of what they've made. So that's basically the tour of the undergrad labs. Like I said, the high voltage lab will show up in the research tour. I haven't introduced myself. If I haven't met you already in the meeting and you're watching the video first, my name is Trevor Smutter, and I am the Director of Undergraduate Labs, so I am in charge of all of the lab spaces and all of the lab instructors in the department. And if I haven't met you already, I look forward to meeting you at the IQAP meeting. Thank you very much for your time, and I hope you enjoyed the VR tour.